Now punch your eyeballs back in their sockets, close your mouth, wipe away the dribble, and keep in mind that you're looking through a glass case at a scale model of the Rolls Royce 24-cylinder sleeve valve H configuration Eagle engine being built by Barry Hares. Put those on my words. 20 years ago, I was looking for a model engineer to help us on the Bluebird project. Someone to do the fiddly stuff, the instruments, the switches, the close fitting plug connectors and hydraulic valves. And I happened across a single solitary entry on the internet about Barry Hares Eagle engine, and I thought, this is the man for us. And I tracked him down. Long story short, we worked with Barry for 20 years. He's become a great friend. And in that time, I've seen his Merlin engine many times. Now, his Merlin engine, there's not enough words. You just have to go back in the playlist and look at the last couple of films I've done with Barry about his Merlin. But he wasn't finished. Barry was just warming up, honing his skills, getting the hang of this. And then he went on to build an Eagle 22 Rolls Royce engine, the last big piston engine Rolls Royce ever attempted, and it never really went anywhere, as you'll find out. Didn't stop Barry, he thought he'd build one of them anyway. And when we met the last time, we had a good chat about his Eagle engine as well. I want to ask about Eagle engines now, if that's all right. Because the Eagle is not, I mean, everybody knows what a Merlin is. The world's cat knows what a Merlin is. And I know what an Eagle is just about, but what's an Eagle?
Well, I was thinking about which engine to do next. There were several Rolls Royce engines which had been interesting to do. The Eagle I dropped on basically because there was one still in existence. It is the only one, and that's at Yeovilton.
Yes, I visited that one in a former life, and I tried to swing off the prop because by then I'd seen yours, and you told me what a big horrible beast it was to turn. And I thought, well, I'm a big horrible beast. If I jump and get a hold of the prop, it might turn over.
It's a big lump.
And it wouldn't budge. I might as well have swung off the church hall. And this is the only surviving Rolls Royce Eagle 22 engine in the world. It's in a Westland Wyvern at the Fleet Aero Museum in Yeovilton in Somerset. And this particular aircraft doesn't fly, it's retired. But this aircraft type did fly for a brief period with the Eagle 22 on board, but unreliability issues put a stop to that. And notice that massive contra-rotating propeller. The energy to drive that must have been colossal.
Well, they only built, from memory, I think they only built 15 engines. There was a tale that one of them existed at Nottingham University, but that came to nothing. So the one at Yeovilton is the only remaining one. I found bits and pieces of the supercharger in the museum at Derby. What's happened to those since, I don't know. But it was the ultimate engine that Rolls Royce designed, although they had trouble with it.
Now, it was for anybody who doesn't know, stop me if I'm wrong here, it's a flat 24-cylinder water-cooled sleeve valve engine.
Yeah, sleeve valve.
Yeah.
Essentially 2 12s, one on top of the other.
Flat 12s?
Yeah.
2 crankshafts?
2 12s. 2 crankshafts.
2 crankshafts. Geared at the front?
Geared together at the prop.
Right.
And then contra-rotating propellers.
And the supercharger and all the gubbins at the other end, same as the...
2-stage supercharger again.
Yeah. By comparison to this, the Merlin's a really simple engine. This thing is 2 engines. It's massively complex. It's a dense nest of impenetrable precision, close tolerance parts, all working together, all sorts of systems. And yet Barry had a look at it and thought, I can make one of those. Every gasket, every widget, every last part of it. So let's get cracking.
It was intended for the Wyvern. They fitted it in the Wyvern Mark 1, but the problem was that it was so unreliable, particularly with the crankshaft, the camshaft drive to the sleeves. That was failing all the time. When it did fail, with aluminium prop, they couldn't bring it in a dead prop landing because it just turned turtle, and it killed 2 or 3 pilots in the process. So they eventually took over with the turbo.
So I assume, having heard everything you said about building the Merlin, that you started with a crankcase.
Well, it's the same scale,
Yeah.
which meant that all the threads and everything were again achievable. It was on the limit as regards the workshop equipment, because obviously it's virtually twice the size of the Merlin.
Mm-hmm. Now, before we get into crankcases and size, it's important to get a hold on the scale of this thing. This is a fuel injection pump for the Eagle 22, and as you can see, it's easy to hold in the palm of your hand. But you'd be wrong to think it was just a facsimile of an injection pump, just a model, because were you to take it apart, you'd find that inside it contains every nut, bolt, screw, rivet, elastomer, gasket, spring, bearing. It has every single thing inside of it. And this is one of my favourite pictures of that pump, because if you look closely, you'll see that it is inbuilt on a single square of kitchen roll. And if you have a mechanical mind, and this doesn't boggle it, then I'm sure that we can find something that will, because that is just incredible. However, again, before we get onto the crankcase, here's a bit of detail from within, because this is one of the crankshafts. And with each crankshaft you get, for example, a full set of these cups, a through bolt, a castellated nut, a split pin, and these go either side of the crank journals, where they've been bored out to save weight but still must contain high pressure oil for lubrication. Barry probably could have found an easier way, but he didn't. And this is what it looks like on a full-size crankshaft. So it is quite involved. And there's more, because if you look at the back end of the crank, you'll see there's a pair of small balance weights with bespoke fasteners that have to be fixed later on. They probably could have been dispensed with. And down here is the ultimate testimony to Barry's obsessive pursuit of correctness and detail: tab washers. I mean, do we really need tab washers? What's wrong with Loctite? But he built them. And he built this. This is the completed crank. You can see the little cups and the journals, the rods with the phosphor-bronze small end bearings, and their castellated nuts. And at the back, there is that little counterweight bolted into place with its bespoke fasteners. It's a mini masterpiece in its own right. And here is the crankcase. The top half is empty. Now remember, this hasn't been designed in CAD. It hasn't been CNC machined. It hasn't been 3D printed. It has been carved from a solid billet of aluminium by a man in his workshop with his milling machine and his dental burrs and his needle files and his abrasives. And note the hundreds of studs in true Rolls Royce style, every one of them 5th scale. The bottom half of the crankcase has all its internals in, cranks, rods, etc. But look at this, because down here is a beautiful set of oil galleries. Now the pipes are probably hypodermic tube, because that's normally what Barry uses, and little hand carved manifolds everywhere the run of pipes changes direction. And you can just bet that were you to take this apart as well, at the end of each one of those tubes there will be an O-ring seal, just to make sure that it doesn't leak. And it runs all the way down the side of the engine and across the back to where it meets the oil pump. This is the other end of the engine, where the gearbox goes for those massive contra-rotating props. It is a piece of jewellery.
When it came to the cylinder blocks, that was about the limit I could machine on a milling machine.
Right. Never mind the limit of what he could machine. Look at the sheer complexity and number of parts there are for the cylinder blocks. This is a 24 cylinder H configuration sleeve valve engine, similar to the Napier Sabre. There's a lot of bits in a cylinder block, and if you're not that familiar with sleeve valves, the clue's in the name. There's a sleeve runs within the cylinder which is moved up and down and oscillated left and right to open ports at the top to allow the inlet gases and exhaust gases to flow.
Right, that's what?
That's the cylinder liner before it was finished,
That's a sleeve.
and that's the sleeve.
So there you go, one inside it too.
Yep.
This is Barry's box of bits, by the way. Spares.
This is the finished sleeve. You can see how the ports work.
Yeah, so that turns inside of there and it opens and shuts.
We get it in the right position. As it oscillates, it opens one then the other.
So one's the inlet and one's the exhaust.
Yep.
So that's constantly whizzing up and down inside of there. And that's one of the cylinder heads. I've never seen this before. So that's, I presume those rings, they fit down into the ball.
Yep.
The rings on the end.
Yeah, they fit inside the sleeve.
Oh, I see.
The other way up.
They're going last then?
Yeah. Because obviously as that moves, if it's up there, the ports are closed and you get the detonation. When it comes down to that position, the ports are open.
So the sleeve slides up and down the outside of that cylinder head?
Yep.
Right. That was the bit I wasn't following. And there's many of those cylinder heads in there. Well, there's 12 on that side and 12 on the other side.
That's one of the cranks that drive the sleeves.
Oh, for the sleeve valve?
Yep.
Hang on, let me get that. Yeah, so that's a spherical bearing in the end.
Yep.
So that wings round and round and opens and closes the
You
ports.
can see it's got the...
Yeah, it's got a little spherical phosphor bronze thing in there, hasn't it? That's beautiful. Beautiful thing.
You see that?
Yes, so that fits on there.
It won't go into there.
It looks
But
really
you can see the
boring.
idea.
Yes, yeah, I can see. It looks really boring and
Now-
repetitive to build that, Barry. What else we got?
That's the drive gear. It fits on there.
So that goes on there. That runs off the shaft that runs longitudinally.
The number of teeth and the number of holes that they hold it are different. They give you a vernier drive.
Oh, so you can clock it round and adjust it.
Yep.
This is an original Rolls Royce photo of the cylinder block assembled, and this is Barry's cylinder block assembled, and you can see the sleeves all at different heights because it's timed in and ready to go. You can see the bronze gears that drive the sleeves, you can see the cams that drive the sleeves, and the through shaft that rotates to push them up and down. But it was this through shaft that was the Achilles heel of the engine. It was failure of that shaft and those bronze gears that drive the cranks that move the sleeves, and these caused the unreliability issues that led to the turboprop taking over.
But it's all the same materials. What was it? EN24T.
EN24T crankshafts.
Cast iron piston rings. And,
HE30 for the aluminium.
right.
And that's about it. Commercial ball races, where I could adapt them, were used by taking, say, I mean, for instance, with the thin wall bearings, which were normally complete whole ball units, you take those out and make cages and put just caged balls back in.
Right.
But generally speaking, it was possible to use commercial balls slightly modified.
With regard to bearings, this is the kit of parts for the gearbox for the front of the engine that drives the propellers. And if you have a look around it, you will see dozens of bearings, ball races. Now, as Barry said, rather than redesign the engine model to suit the bearings, he redesigned the bearings to suit the engine model, just to make sure that he got everything absolutely right. And that front end of the engine is a thing of beauty. All the gears are cut to absolute perfection. They all mesh to absolute perfection. There's tab washers, there's the final studs. And again, look at the ball races on the front on the gears. There's not a single detail missed out here.
And this one is the one with the Magnetos that that you wound from.
Yeah, but then again, the Magnetos work simply because of rare earth magnets.
Ah, right.
Without that, you wouldn't get them to work.
So you didn't have those for the Merlin?
Yeah, they were rare earth again in the Merlin.
Oh, okay.
But the Magnetos and the Eagle are a different kettle of fish altogether because they're twin spark mags, and each mag does 2 lots of 12 sparks per rev.
Right. 24 sparks
Yep.
per revolution.
Well, simultaneously, 2 simultaneously.
Right.
But
Because there's 2 plugs per cylinder, isn't there?
Yep.
On the Eagle, yeah.
But the interesting bit with the Magnetos, when it came to designing them and making them, you have 2 magnets and 2 coils in a crucifix configuration, with then a 6-pole rotating armature. So you get 12 sparks per rev.
Much the same as the fuel pump. Were you to open up a Magneto, you would find inside every last tiny component, all meticulously reproduced, right down to the very finest detail. And I don't know what half of these parts are, but if I could choose a part that I do understand and like, it's these tiny points with platinum electrodes and Tufnol insulators in the distributor. That's something I can get my head around. And it's not just guessed at. There's lots of drawings that go with Barry's engine. This is a plug connector, and this is the connector in the top of the Magneto for the crossover cable that goes to the other Magneto. In the bottom is the connector for the spark plugs, and that has its own bespoke plug connector, and all the wiring for the spark plugs is in trunking with braided connectors, with threaded connectors to go onto the plugs themselves. And at the top there is the crossover cable that runs from one Magneto to the other across the top of the engine. This is the finished installation, and as ever it is an absolutely perfect working recreation of the Eagle 22 Magnetos.
Now the fun is that when you work it out on paper, if the coils are the same, the sparks are simultaneously the same polarity. And the problem then occurs with the distributor that whether opposite polarity, when they're opposite polarity, the sparks will jump between each other rather than going down to the plugs.
Right.
So you have to wind the one coil opposite to the other.
Oh, my brain is going to explode.
So the coils are not identical.
So you're winding coils with your less than a thou thick mobile phone earpiece wire that you've just unwound,
Yep.
opposite handed,
Yep.
to determine the polarity of the sparks,
That's it.
to make sure they go as far as the plugs.
Yep.
Yeah, and what you're going to tell me is that it's quite simple, it's just repetitive.
It drives you mad.
You're not going to say that.
As I say, I did those 40 years ago. I don't think the dexterity and eyesight would react to that now.
I don't think there's many people in the world, and I know a lot of people agree with me, I don't think there's many people in the world that have ever had the eyesight and the dexterity.
Yeah.
You know, even when I was younger in my prime, I don't think I could ever wound something like that. You know, and I remember Peter Graves saying this to me. You know, he said it's absolutely exceptional. You know, you've never seen anything like it. And I'll say to people, your name will come up. And I say, "Oh, have you seen Barry's Eagle engine?" I get it up on the internet and go look at it, and they just go, "What? Wow!"
I've still got some of the wire.
Yeah,
Yeah.
I've got some of the wire. One thing I've never asked you, stupid little thing. On the front of the Eagle, now you've got the 2. I don't know how to describe them, the 2 little barrel-shaped things.
Yep.
You said there was something to do with advancing the ignition timing, I think. The 2 little things on the front of the...
Yeah, the ignition timing on the Eagle is interesting because what it is, the drive to the Magnetos is a small shaft which has a parallel gear on one end and a helical gear on the other.
Right.
And it can move axially. Now that's driven by oil pressure. So as the oil pressure increases at startup, it moves the shaft axially, so the helical gear in effect moves the drive to the Magnetos because of the helix angle on the gear.
Right.
So that it's a crafty way of altering the timing.
And I think, again, correct me if I'm wrong here, but the Eagle was a cartridge start system.
Yes.
Now, for anyone unfamiliar, the cartridge start system does exactly what comes out of the tin. It's just a big shotgun cartridge, and that is fitted into a breech on the aircraft and locked into position. and then it's fired remotely, and a blast of gas from a black powder explosion kicks the engine around. But the Eagle 22 is such a monster, it needs a start cartridge system with a half a dozen cartridges in it. And as you might expect, Barry took the drawings and created an absolutely perfect version in miniature. And there is a really fun story goes with this, which we'll get into the next time. And then of course there's other things. There is, for example, the twin stage supercharger system, which has lots of bits and all works as usual. There is the aftercooler with its gaskets and its heat exchanger and its many Rolls Royce studs. There's those huge counter-rotating propellers with all the gubbins that makes those work. And tiny engine accessories, vacuum pump, hydraulic pump, air compressor, generator. And they run off a tiny and very complex accessory gearbox that isn't even part of the engine, and which Barry didn't even have to build. And yet he still built one. Well, there you have it for now. There's still a lot of Eagle to look at, but it's quite involved. It takes a little while to put together. So we'll do another Eagle film in due course and get that uploaded. In the meantime, I'm going to go and see Barry next week with a bunch of questions. Some of my questions and some of your questions that you've sent in. So if you have any more questions for Clever Barry, please get them in quick as you can. And if you're enjoying this, of course, don't forget to like and everything else that comes with it. Another thing that, fingers crossed, we're going to do is to get Merlin Peter Grieve down to see Barry's engines and get his opinion, which ought to be interesting, seeing as he's spent a lifetime working on the full-size items. So we'll try and put that together too. So in the meantime, thank you as ever for watching, and we'll see you on the next one. And whatever you're doing, have a good one. See you shortly. And if you like this content, don't forget to do the like, subscribe thing here, there. And yeah, we'll see you on the next one. Where is it? There.